Okay, today we're going to talk about this new thing I'm going to try to build. And it's a good thing we didn't buy the parts yet, because I was going to buy them and I was going to leave out the diode. And then Flyback on my chat said that it's probably what he could have used is an audio transformer instead, which then would leave the diode out, and it'll probably want to modify the audio signal on the output and make it much worse. Anyway, so what the diode will do is it'll prevent the inductive load, if it's an inductive load. But just to be safe than sorry, we're gonna put a diode across the higher voltage component that takes the 3.7 and steps it up to 18,000 volts. It should draw about up to like 4 amps or so. So I gotta get a 5 amp power supply. It's gonna be 12 volt 5 amps. But the thing is, I'm gonna use a voltage regulator that can step it down to 3.7 or so and adjust it. And we're gonna make it so it can adjust it, change its power, its output power, or the volume control. Anyway, let's take a look at this circuit. Okay, here we got is our circuit diagram. It's very simple and easy. It takes a 12 volt or a 6 point, we want as lowest voltage you can, but it cannot go below 6.85 volts. This is because it must have at least enough differential voltage that cannot go below 3 volts or so. Can't use 5 on it, because 5 minus 3 is 2 volts. It only works if you're regulating 2 volts. Anyway, what the regulator will do is it'll step down the voltage, so it's safe voltage for the high voltage component to run off of the module. The 240 ohms right there is usually what they use for this regulator to V for R1 in the equation. R2 is 500 ohms, variable one. Why I made it variable? So I want to be able to change the strength on it. If you do not want to make it variable, you can use 510 ohms or so. Just don't get too higher than 500 ohms. The higher it goes, the more voltage it'll make. Anyway, after that, we go to here. There's a diode across there. It's important that you have a diode. You could also put in the audio transformer in it, like Flyback said. But I think if you have a diode on there, it's just good enough, because it will prevent the inductive kickback voltage on it. They use the same thing in relays with computers. They always put a diode on it. The diode protects the circuit from that high voltage created by it, if it creates it on it, because who knows, that thing could have an inductor inside it, and it could be making, and it could generate a kickback voltage once it turns on. So you make sure you have that diode placed in there. Also, make sure your transistor is weighted for the 4 or 5 amps it generates. See, what I'm going to use down there is a TIP 35CP one. You can find that as all electronics as well. We'll go look at the data sheet in a few minutes. That there is acts like a single-ended Class A transistor amplifier. Kind of like that. It's done like a switch, but it works with the audio signal. Since if you look on YouTube for a single transistor audio amplifier, you'll find a circuit similar to this. If you look on my website and look at the audio to relay transformer, it's similar to this too as well. And that's what generates. That's how it's going to generate the high voltage on the output side. If you don't have no sound source connected to it, it'll still be on, because as you can see here, the positive voltage will flow through there, then to there, then it goes to that there over here to that resistor there, which applies to the base. So if there's no audio signal there, it'll be applied to base and it'll go on and it'll turn it on. I think when the audio is it weakens the signal, weakens that voltage to make the oscillation, match the oscillation with it. If I'm correct. And the transistor is audio amplifier transistor, not just a general purpose. It's also used applications for audio amplifiers, which should do good. And we'll have the probes mounted ½ an inch apart so they can arc. There's probes on it. You'll see it if you look at the web page of mine, where about the component you're gonna get to make it. Now enough about that. Let's talk about the transistor. There's our transistor right there. Complementary power transistor. Low features: low collector emitter saturation voltage. Complementary NPN PNP transistors. I have the simplest circuit that does what I'm trying to do, but I couldn't get it to work because I didn't know why. Probably because not reading the manual good enough, or the board being double-sided. I don't know if it's double-sided or not. It might have been, and that's why probably part of the circuit didn't work, because only one LED lighted up, and then on the Tesla coil it didn't, arcing or sounding. Anyway, I'm going to use a module that make this thing simpler, because it'll already generate the high voltage that we need. This device is our manufacturing planner technology with base Ireland. The resulting transistors show exceptional high gain performance, coupled with very low saturation voltage. Then if you look at the maximum weighting, we got collector base voltage and collector emitter voltage. They're both 100 volts. The base emitter voltage is 5 volts, but I don't know why they'll say such a thing like that, when I know transistors I've been using have been able to handle more than 5 volts on it. Maybe that's something to do with, don't know what that has to do with anything. I have no idea what that's for, because I have been switching signals and they've been going through the middle base section of the transistor, and they're higher than 5 volts, and the transistor never breaks. Could be because of the resistor. Maybe that's when it's at 5 amps on the base current. Maybe that's what it is. If you have 5 amps going through it, it must be 5 volts. Total dissipation, well, the power of it is 3.75, or or is equal to 2 times 4 times by 5, which will give us around in the tens range. Yeah, around in the 10s or 20 ranges. So it's to be way less than 125 watts. So this trends, they say right here, applications, you can get this, show it, application, general purpose, and audio amplifier. So there you go. Now I have to order the parts and see if we put it together and see if it'll work like we want it to. It may work like we want to, or it may not, because who knows, it could draw enough current on it that the thing just wants to be latched on and stay latched on without changing. It's a possibility, because I have the thing is, the resistor could need to be changed, but that's, I don't know. We'll just give it a go, see how this way works. So we have to stay tuned to see what I put together and see if the voltage across it is, well, not the voltage, if it can handle that current, the transistor, and switch it on and off and replicate the signal like we want to. Okay, so stay tuned for that video. Thanks for watching. If you like it.